Click one, erase, there we go. Okay. Lesson 5.2. The multiple angle formulas. Okay. We already know now that the sine of u plus v is the sine of u cosine v plus cosine u sine v. We know that from the lesson we just did. What if u is equal to v? That's the question we now ask. What if u is equal to v? Well, if that's the case, Kate, then this becomes the sine of u plus u, which is equal to the sine of 2u. So this is called a multiple angle because it's multiplied by 2. Well, all I have to do now, Caitlin, is replace v with u, and this becomes the sine of u, cosine of u, plus cosine of u, sine of v, sine of u again, because I'm replacing v with u, and these are the like terms, so these can actually add together to give me 2 times the sine of u, cosine of u. And so this is called the multiple angle formula for sine. So if you have the sine of 2 times an angle, that's the same thing as 2 times the sine of u times the cosine of u. So what happens with the cosine? I know that the cosine of u plus v is equal to the cosine of u, cosine of v, minus the sine of u, sine of v. But again, if u is equal to v, if they're the same, then this becomes the cosine of 2u, u plus u, and this becomes cosine u, minus sine u. So this is cosine squared u minus sine squared u. Like that. Does that make sense? Okay. Now, because of the identity that's down underneath the board, because cosine squared u plus sine squared u equals 1, there are a couple of other possibilities here. I can replace the sine squared u with 1 minus cosine squared u. So this becomes cosine squared u minus 1 minus cosine squared u. And if I distribute the negative, this becomes negative 1 plus cosine squared u. I combine like terms, and so I get 2 cosine squared u minus 1. That's another possibility. So now I have 2 possibilities here for cosine of 2u.
Could you also have like
Yep.
1 minus?
I could replace cosine squared u with 1 minus sine squared u. So I could also say, okay, 1 minus sine squared u, replace that here, minus sine squared u, and that gives me 1 minus 2 sine squared u. And so it turns out that for the cosine of 2u, I have 3 potential answers. They're all the same. Okay? They're all the same equivalently. They give you the same real number every time. So they're all equivalent. Okay? But you do need to know the 3 possibilities that you can get from cosine of 2u.
My question is, like, what is easiest to use?
I usually gravitate towards this one. I like that one personally because it keeps cosines in terms of cosines. That's why I like it. You do need to know all 3 because sometimes you'll have an expression that looks like this and you'll need to know how to change it. I know from the previous lesson that the tangent of u plus v is equal to the tangent of u plus the tangent of v over 1 minus, bless you, tan u tan v. But again, if u is equal to v, if they're the same, then this becomes the tan of 2u is equal to, these are now the same, so this becomes 2 tangent of u over 1 minus tan squared u.
It's the same thing with B if they wanted to have. Yes.
Correct. So these are the multiple angle formulas right here. And so now we can actually take equations and we can solve them. Two times the cosine of x plus the sine of 2x equals 0. This is a multiple angle, so I replace this now. I'm going to use the substitution property. This becomes 2 sine of x cosine of x, just like that. Now for my formula.
Wouldn't you want to take out 2?
Say that again?
Would you want to take out the 2?
And what else? Yes. So you take out a common factor of 2 in cosine. So this becomes 2 cosine x times 1 plus sine x equals 0. Now I use the zero product property, which says that this could be 0, 2 cosine of x equals 0, or this could be 0. But if that's 0, then that means that the sine of x is what? Negative 1. And this just means that the cosine of x equals 0. And now I think back to my circle. Okay, when is the cosine of x equal to 0 in the unit circle? At 0, it would be 1, and at pi, it would be negative 1. Pi over 2 and 3 pi over 2, those are the two solutions for this equation. And when does sine equal negative 1? 3 pi over 2, so just right there. So my solutions to this equation are here and here. And what angle are they separated by? 180 degrees, or pi, right? So my solutions are x equals pi over 2 plus pi n, where n is an integer. So n could be 0, and if n is 0, then I just have pi over 2. If n is 1, then I have 3 pi over 2, and then after that it keeps winding and winding and winding around each time. And those are my solutions. Any questions on that? Does that make sense? Okay. All right. Let's look at the next one. Let's see. Use the double angle formula to rewrite the equation. So let's say I have an equation, y equals 4 cosine squared x minus 2. And I want to rewrite this equation. So I want to get a function that's equivalent. It's the same in value, but it's simpler. So what I do then is I factor out a 2. And 2 cosine squared x minus 1 is what? Cosine of 2x. So this can be substituted with the cosine of 2x. So this becomes 2 times the cosine of 2x. This right here, Caitlin, is equivalent in number to the original. They all give you the same real number, okay? But it's way simpler because it's not a square. It's called a reduction in power.
Wait,
reduction in power.
What happened to your 2?
What happened to my 2?
Yeah.
That's my 2 right there.
Okay.
And then this right here, if you look back at that chart at the beginning of 5.5, this can be replaced with the cosine of 2x. It can be substituted. Do you remember how to find the period?
Oh.
What's the period of plane cosine? 2 pi, right? So what you do is you take 2 pi and you divide it by what we called b, which was the number multiplied by x on the inside.
What's this pi?
So the period of this function is normal pi. It has an amplitude of 2, so the function looks something like this. Goes up 2, has a period of pi, so here's pi over 2, here's pi over 4, here's 3 pi over 4, and it goes down 2, so it looks something. It's going to go, let's see here, down like that. And if you graph this in your calculator right here, 4 cosine squared x minus 2, you'll get exactly the same thing. I'm going to go ahead and do that. I'm going to show you that it's the same. Or cosine of,
It's cosine squared x. So cosine squared.
yep, that's what I have here. There we go. Alright, I was misinterpreting it. There we go. So this turns out to be the exact same thing. Now look at this, Abby. I'm going to say y equals 2 cosine of 2x. Should I see any difference between the graphs? I hit enter. They overlap each other perfectly. They are indeed the same function. But would you agree with me that 2 cosine 2x is easier? It's easier because it's a reduction in power. It's not the square. So it's nicer. Okay. So that's what we're doing. We're making functions a little bit nicer than what they've been. Okay. Now, if I know that the cosine of theta is equal to 5 over 13, and I know that theta lies in quadrant 4, this puts it in quadrant 4, what is the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta? Okay, so the very first thing I'm going to do, Doris, is I'm going to draw a picture. So I draw my y-axis and my x-axis, and I'm going to put this in quadrant 4. So my angle goes like this. There's my theta, quadrant 4. Cosine is adjacent over hypotenuse, right? So this has to be the 5, and this has to be the 13. When you solve for the unknown side, you're going to get negative 12. Has to be negative. Why does it have to be negative? It's in the 4th quadrant, and the y value has to be negative in the 4th quadrant, right? Now, we can find this next because we know that the sine of 2 theta is the same as 2 times the sine of theta times the cosine of theta. We now know that that's true. And the sine of theta, what is that? Well, it's negative 12 over 13. Cosine of theta, 5 over 13. And so when you multiply this all together, you're left with negative 120 over 169. And that's the sine of 2 theta. Does that make sense? Okay. What is the cosine of 2 theta equal to? Well, again, I like to use 2 cosine squared theta minus 1. So I already know the cosine of theta. It's 5/13. So this becomes 2 times 5/13 squared minus 1. Now, 5 squared is what? 25. 13 squared is 169. What's 2 times 25? So this becomes 50 over 169 minus 1. Now I turn this into a 169 over 169. And if you take 50 and subtract 169, you should get negative 119. And there's your cosine of 2 theta. How are we doing so far? How are you feeling on this stuff? No? Okay. All right. Let's say I give this one to you. Let's say I have, I'm going to do sine this time. I know that the sine of theta is 1/3. And I know that theta is just in the good old first quadrant. Let's say I know that. What is the sine of twice the angle? So what I'm going to do is I'm going to draw what I already know. So I already know, here's my triangle. This has to be a 1. This has to be a 3. Opposite over hypotenuse. There's my 1/3. So there's my angle theta. Now I'm going to use the formula that's in this section. Okay? The formula in this section says that the sine of twice the angle is the same thing as 2 times the sine of theta times the cosine of normal theta. So this is just 1 times the angle in each of these. And those I can find because I have the picture to help me find them. So I use the Pythagorean Theorem. X squared plus 1 squared equals 3 squared. So x squared plus 1 equals 9. So x squared equals 8. So x equals the square root of 8, which is 2 square roots of 2. So this has to be 2 square roots of 2 right here. Now, sine I already know. What is the sine of theta? It's 1/3. So I'm going to substitute. I'm going to replace the sine of theta with 1/3. 2 times 1/3. And I'm going to replace the cosine of theta with what? Adjacent over hypotenuse. So here's the adjacent, which is this, and the hypotenuse, which is this. 2 square roots of 2 over 3. Now I just multiply all the numerators. 2 times 1 is 2, times 2 is 4, so that's 4 square roots of 2, and I multiply the denominators, and that's 9. And that's what the sine of 2 theta is equal to. A little bit more sense? Okay, so we just keep practicing with it. Now, what is the tangent of 2 theta? Okay, well, if I go back to the beginning of this section, what's the formula for tangent of 2 theta? At the beginning of the section.
1 minus 2 sine squared u.
Oh, they have a couple, don't they?
2 tan u over 1 minus tan 2.
Yes.
Squared u.
2,
Okay.
you remember that I like to use little limericks? So I like to say that this is 2 tan u over 1 minus tan tan.
I have a quick question.
Yes.
Okay, so 5.5 and 5.4, they have equations,
Mm-hmm.
but they use their different for uses. How would you decide which one to use for which?
It's going to give you in the problem. It's going to give you from the problem. You're going to be able to use the formula. If you're dealing with an angle like 11 pi over 12, you have to break that up into 3 pi over 4 plus pi over 6.
So,
2 different angles.
right.
So that's a 5.4 problem.
Okay.
Okay? Now, let's say you were dealing with that would be a half angle. If you were given a problem like this, where you want to know the sine of twice the theta, then that means you're going to be dealing with 5.5.
Okay. because you need to, because
Right.
you're just using one theta.
You're just using a simple one angle, yes.
Okay.
So if you have to break up an angle into two different angles,
And you use 5.
then you do 5.4.
But if you just need one.
But if you want twice that measure and just twice that measure, then you're in 5.5.
Okay.
And what I hope you see is that all of the formulas we have in 5.5 come right from 5.4. They come right from there. So they're not really new, they're just a special situation. What's the tangent of this angle here?
It's 2 over 3.
Right. So this becomes 2 times 1 over 2 square roots of 2.
Square root of 2 over 4.
And this becomes 1 minus 1 over 2 square roots of 2 squared. Do you see that the 2's divide away here? So I'm left with 1 over square root of 2, 1 minus, okay? Now, you can't see it because it's at the bottom of the board. This is a 2 square roots of 2 squared. What is 2 square roots of 2 squared? 8. So this is 1 over an eighth. So now 1 minus an eighth is 7/8. So this becomes 1 over the square root of 2 over 7/8. Reciprocate, 8 over 7. So 8 over 7 square roots of 2, and now rationalize.
Where'd you get the 7?
1 minus 1/8 is 8 over 8 minus
Right,
1/8.
Okay, gotcha.
7/8. Rationalize this. This becomes 8 square roots of 2 over 14, and then reduce that. 8 over 14 is 4 square roots of 2 over 7. Okay? Okay. Sine of 3x. The sine of 3x is equal to the sine of 2x plus x. Now, is 2x the same as x?
No.
Not a chance. So what do we have to do? We've got to use 5.4 because they're not the same. So this becomes the sine of 2x cosine of x plus cosine of 2x sine of x. Yes?
Why couldn't you just call it an x? So you had sine x.
Why couldn't I pull out an x like this?
Yeah. 2, you mean?
Well, 2 plus 1.
Oh, okay. Yeah.
Because this is a function. This is not sine times.
Okay.
This is the
Gotcha.
sine of 2x and plus x goes inside the sine function.
Right.
So you can't factor out the variable out of the function
Gotcha.
because that's not multiplication. But this we know now. We know what the sine of 2x is. What can I replace this with? According to 5.5. 2 sine x, cosine x, and then cosine x. Plus, what can I replace this with? I've got a couple of choices. I'll replace this with 2 cosine squared x minus 1 times the sine of x. Now this becomes 2 sine of x cosine squared x. Does everyone see that? And this becomes distributing. Now right here, Abby, I can distribute because this is multiplication now. So plus 2 sine of x cosine squared x minus the sine of x these two guys right here are like terms. Because I have sine x cosine squared, sine x cosine squared. So that's 4 sine of x cosine squared x minus sine of x.
How is that any less complicated than what you started with? Like, you started with sine 3x.
It is.
Sine 3x looks so much simpler.
Okay? Now, you asked a good question. How is this less complicated? And it is less complicated. I'll grant you this. It's not less complicated in power, right? Because we have a cosine squared here. Okay, so it's not less complicated in power. But it is less complicated in this sense here, Sydney. This is 3 times the angle. Whereas right here, and here, and here, that's just the angle.
Okay.
And sometimes you don't know what 3 times the angle is. But you do know what the cosine and the sine is of the regular angle, right? In that way, it's less complicated. So sometimes it's important, you have to take a multiple angle like this and transform it into just x. Sometimes you'll have a 5x, cosine of 5x. You'll need to do what you need to do to turn it into something with plain old x, because that's something you know and that you can work with.
Okay.
Does that make sense? So in that sense, it is less complicated. Okay. We have not yet gone over the power reducing formulas, and that's okay. That is okay. We are doing 44. 44, is that?
That was for 5-4.
Oh no.
I think that's 44.
Yes, that was. Okay. 12 through 36. I want to make sure we're on the right track. 12 through, use double angle formula. Oh, can't use double angle formula yet. Okay. Okay, right now, I'm going to modify what's on the board here. Let's see, today's Thursday. So, first 12 through 28 evens that you can do.
What about like 18 with the 4? Do you just do it like the one we just did?
Like an x. So you use theta as like an x.
Ask me that again, I'm sorry.
Like number 18, then it's here 4x.
Yep.
You do it just like one we just did.
Yeah, if you have tangent
Or is it more like
of 4 theta, that's equal to the tangent of 2 theta plus 2 theta. So then you use your formula.
But they're the same.
And so if they're the same, then this becomes 2 times the tangent of 2 theta over 1 minus tangent squared
Oh, okay.
2 theta. But now you can use your double angle formula again on that.
Wait, so it acts more like a u plus u?
Yep.
Okay.
This can be broken up into 2 theta plus 2 theta. So that's why it works.
Okay.
So this is what I've modified it to be. I want you to do 12 through 28 evens. Those are the ones that you can handle. Okay?
Yeah.
All right. I want to see your books open. I want you to use the remaining 7 minutes, whatever we got, to at least start on it. Get it out of the way. And as far as the video goes, God bless you wherever you are today, if you end up watching it at home.